Forming quadratic equations. Learning intention. Form a quadratic equation from given roots. Success criteria. I can use the roots or1 and or2, the two solutions, to write the factors x minus or1 multiplied by x minus or2. Expand and simplify to get ax squared plus bx plus c is equal to 0. Clear fractions if needed. Check the equation has the correct roots. Examine the quadratic equation x squared plus x minus 6 is equal to 0. The factors of the left-hand side are x plus 3 multiplied by x minus 2. So if we were to factorize this quadratic trinomial, we would end up with x plus 3 multiplied by x minus 2 is equal to 0. So if x plus 3 is equal to 0, then x must be equal to minus 3. And if x minus 2 is equal to 0, then x must be equal to positive 2, i.e. minus 3 and 2 are the roots of the equation. We can now use the reverse of this method to form quadratic equations when we are given the roots. Example 1. Form a quadratic equation with the roots minus 4 and 5. So we start with two sets of brackets with an x in the front of both brackets. We're going to change minus 4 to positive 4 and put it into one of the brackets. And then we change 5 to minus 5 and put it into the other bracket. Then we'll multiply out our brackets, we'll expand our brackets. So we'll have x multiplied by x minus 5 plus 4 times x minus 5. Which gives us x squared minus 5x plus 4x minus 20, which gives us x squared minus x minus 20 is equal to 0. So x squared minus x minus 20 equal to 0 is the equation with the roots minus 4 and 5. Or we can use the array or the box method. So we have x plus 4 down one side and x minus 5 down the other side. X by x gives us x squared. X by 4 gives us 4x, x by minus 5 gives us minus 5x, and 4 by minus 5 is minus 20. Then the 4x and the minus 5x will simplify to give minus 1x or minus x. So again, we have x squared minus x minus 20 is equal to 0. If x equals a half is a root of an equation, then x equals a half gives us 2x is equal to 1. So 2x minus 1 is equal to 0, and 2x minus 1, therefore, is the factor which gives this root. Similarly, if x equals minus a third, then 3x is equal to minus 1, and so 3x plus 1 is the related factor. Example 2. Form a quadratic equation whose roots are minus a quarter and 3. So we started off in the same way as before, two sets of brackets with an x in the front of each bracket. Minus a quarter changes to positive a quarter and goes into one of the brackets. And 3 changes to minus 3 and goes into the other bracket. Then we expand our brackets or multiply out our brackets. So we have x times x minus 3 plus a quarter times x minus 3. That gives us x squared minus 3x plus a quarter x minus 3 quarters. Be careful now when you're using fractions. So that simplifies to x squared minus 11 over 4x minus 3 over 4. And we let that equal to 0. We're going to multiply by 4 just to get rid of the quarters. So we have 4x squared minus 11x minus 3 is equal to 0. So here we have our quadratic equation that has roots minus a quarter and 3. Or we can use the array method. So we have x plus a quarter on one side and x minus 3 on the other side. X by x gives us x squared. X by a quarter gives us a quarter x. Minus 3 by x is minus 3x. And minus 3 multiplied by a quarter is minus 3 quarters. And then a quarter x minus 3x will simplify again to give us minus 11 over 4x. And we multiply across by 4 like before. And again, we get 4x squared minus 11x minus 3 is equal to 0.